This was a quiz about solving exponential equations. And it's only 5 questions long. I'm going to go over these questions right now. Yeah. Alright, on problem number 1, we see the variable on both sides. Exponents on both sides. So, I'm thinking like bases are the way to go. So 125 and 25, you look at your chart. Oh look, 125 and 25, they're both a base 5. So 5 squared and 5 to the third power. Alright, so this 125 is 5 to the third power, and 25 is 5 squared. Now, this x, that's an exponent, so it's going to go up here with the exponent. Same with x plus 1, but you should put it in parentheses. Alright, so that means 3x is going to equal 2 times x plus 1. If the bases are the same, the exponents are the same. Of course, you have to distribute, so we will have 3x is equal to 2x plus 2. Go ahead and subtract 2x from both sides, and that's just going to give you x equals 2. Alright, I'm going to go ahead and say it. Easy peasy, lemon squeezy. So then on number 2, let's add 17 to both sides. So that's going to give you 6 to the x power equals 35. Time to rewrite this in log form. Start with the base. So we will write log base 6. Alright, now of course these two things will have to change sides. So the 35 will come over here, and the x will come over here. Okay, so this can just go in the calculator. Well, not so fast actually. This can't go into the calculator just like this. We need to use the change of base formula. So this will be the same thing as log 35 over log 6. Now that is a form that will go in the calculator. So we're getting 1.98. Alright, that's it for number 2. Okay, number 3. This one doesn't have logarithm in it. Well, I guess that one didn't either, so you're not surprised. In fact, never mind, I'm thinking of something else. Okay, so let's get the, we need to get the base and the power by itself before we do anything else. So we need to get this part by itself. Am I going to divide by 2 first, or am I going to subtract 3 first? Kayla, come look at this for a second.
Okay.
Alright, I'm trying to get this by itself, the yellow part. Am I going to divide by 2 first, or subtract 3 first?
Subtract 3.
Alright, very good. Carry on.
Okay.
I'm going to subtract 3 on both sides first,
And then divide by 2.
and then we'll divide by 2.
There's 6 on one side.
Excelente. Okay. She's going to be really scary when she gets to high school. Alright. 1 year away. Yeah. I don't want to tell you that she's been able to solve problems like this since she was in elementary school. I won't even mention that. Alright, so that's going to be e to the negative x power equals 6. So now we need to go ahead and write this in log form. So this is base e. So bring down the e, but we'll do log base e. Now I know what you're thinking, but Mr. Burton, we don't do log base e. Well, just keep your shirt on. So there's our base e. These two things are going to change sides. So the 6 is going to come over here, and the negative x is going to go over there. Notice this 6 is not a power. Alright, if I see this on your paper, log e to the 6th power, if I see this instead of this, I'm marking it wrong, and we'll both be real sad about it. This e needs to be low, this 6 needs to be on the same line with the log. Anyway, you're right, we don't write log base e. That means natural log. So this is the natural log of 6 is equal to negative x. Which means that x is equal to the opposite of the natural log of 6. Technically, you could say I multiplied both sides by negative 1. Or if you like to think of it as dividing by negative 1. Either way, both signs change. So now we are in a position to know the final answer by putting this in the calculator. Negative natural log 6. So negative natural log 6. And there you go, negative 1.79. Alright, phenomenal. Number 4. How long does it take for an investment to double at an annual interest rate of 12% compounded, wait for it, continuously? Well, that continuously tells us that we are looking at the PERT formula. P times e to the RT power. Okay, now it doesn't tell us what the initial amount is or the final amount. But look, if it's gonna double, I'm sorry. If it's gonna double, if P represents the initial amount, yeah, Kayla, come back over here.
Okay.
Okay, you've never seen a problem like this before, but I'm just gonna tell you that this P represents the initial amount of money that you're gonna deposit.
Okay.
Okay. Now, the problem says that the investment is going to double, so we need to know how long it takes to double. So, if this represents the amount that we will have then, all right? If the initial amount is P, what would be an expression representing the amount once it doubles?
Let's see. Doubles once.
Yeah, if the initial amount is P, if it doubles, how much will there be?
2p.
2P. Very good. Carry on.
Yeah, I know how to do this.
So, that would be 2P. The initial amount is P, the eventual amount will be 2P, and so then we just solve it from there. But the beauty of it is, alright, well, we also know the interest rate, 12%. So that means R is 0.12 as a decimal. Okay, so I've got 2P is equal to P times e to the 0.12 t power. Now I'm trying to find t because it says how long. I don't like having this extra variable of p. But that's okay because if I divide both sides by p, the p's go away. And so really what I have is, let me bring it over here, I have 2 equals e to the 0.12 t power. Anyway, if I want to solve for t, I need to rewrite this in log form. Start with the base. You got to bring that down and do log base. So this is base e, so I'm talking log base e, okay? These two parts are going to change sides. So I'm going to have 0.12 t over here, and I will have 2 right here. Notice it is on the same line as the log. The e is low. This is not an exponent. Cannot overemphasize that. Anyway, and you're right, we won't put log base e. Once again, that is natural log. So what I really have is 0.12 t is equal to natural log of 2. To get t by itself, we will simply divide both sides by 0.12. Kabam. So then I will have t equals, and I can just put this in my calculator, natural log 2 over 0.12. Okay, so natural log of 2 over, alright, so that's 5.78, round up. Alright, so we're talking years, so it would take almost 6 years for the investment to double at this interest rate, compounded continuously. Okay, let me show you one other thing real quick. Alright, imagine, say if you didn't understand fully that thing about the P and the 2P. They wanted to know how long it takes for an investment to double. What you could do is just pick any random starting amount and see how long it takes to double. So for example, I could have said, okay, I'm going to start with $100. Okay, so that'd be 100, and then the rest of it would be the same, right? And if we're asking how long will it take to double, then $100, of course, will become $200. So as you begin the problem, and you go, okay, well, let's divide both sides by 100 to get e by itself. Okay, well then look what happens. 200 divided by 100 is 2. So we get 2 equals e to the 0.12 t power. Now, does that look familiar? Okay. So you don't have to do the p thing. If you want to, you can just pick a value and try it out, and you'll get the same answer. All right. I think there's only one more problem. This was the shortest quiz I've ever given you guys. You invest $500 at 6% interest compounded quarterly. How long will it take for the investment to reach $20,000? Compounded quarterly. So you have to know which one of those formulas we're going to be using, and we will be using, no, not that one, not that one, this one. Alright, if we're talking about quarterly, that means n is 4. Alright, quarterly means 4 times a year. Okay, so according to that formula I just showed you, the eventual amount, I'm just going to write down the formula again. Principal times 1 plus the rate over n to the nt power. Okay, you invest $500. Alright, that is your initial amount. Okay, so that is your P value. That's going to go here. Eventually, you have $20,000. So that is your Y value. Alright, and of course, the quarterly, we already said that's going to be n equals 4. So let's plug all this in. Oh yeah, and the 6%, that tells us that the R value is 0.06. So plugging in all those numbers, we have 20,000 is equal to 500 times 1 plus, alright, the R is 0.06 over 4 to the 4t power. T is the one thing we don't know, okay, because they're asking us the question, how long? Alright, that's t, that's what we're looking for. So somehow we have to solve this for t. We will start by dividing both sides by 500. Okay. Okay. 20,000 divided by 500 is 40. So we've got 40 is equal to 1 plus 0.06 over 4 to the 4t power. Okay, I'm running out of space. It's time to rewrite this in log form, ugly as it is. This in the parentheses, this is the base. So when I rewrite this in log form, I need to make sure that that is my base. So I'm going to write log base, and so my base is this whole thing, 1 plus 0.06 over 4. Okay, that's my base. Now, these other two guys have to switch sides. So the 4t is going to come over here. Alright, so there's my 4t. And the 40 is going to come over here to the right. Now this is no longer an exponent in log form. This is not to the 40th power. This is just on the line. So anyway, so I've got log base this of 40. We still need t by itself though, so we will divide both sides by 4. So we will divide all of this mess by 4. Okay, so what I like to do is type all this in my calculator. Oh yeah, but one more thing. I guess we can't type this blue part, the numerator, directly into the TI-30. It doesn't understand it. So we have to use the change of base formula, and this blue part can be rewritten as log 40 over log of the base here. Okay, so over log 1 plus 0.06 over 4. Now that is the blue part, so I'm going to sort of keep it color matched here, and that is all over 4. Now please notice that all of this is the numerator, okay, and the only thing in the denominator is the 4. Alright, the blue part is the numerator, and the single pink number is the denominator. Alright, that's important for when you go to type this in your calculator. Alright, so watch how this goes. So obviously we're going to need a fraction, so fraction mode. Now the denominator, let's do that first just to make it really obvious. The denominator is simply 4. Okay, that's it. Now the numerator has a fraction in it, so you need to hit the fraction button again. Now we have a fraction in the numerator. So we will type in the blue part now. So we have log 40 up top, and in the lower part of the numerator we have this ugly thing. So log of 1 plus, and time for another fraction. Okay. Alright, over 4, and then close those parentheses. So this is what we have here. So if I hit enter, that is going to be my answer. So 61.94 years. Alright, almost 62 years. Now, some people are uncomfortable typing in this fraction, or, I say uncomfortable. Some people are unsuccessful attempting to type in this complex expression into the calculator. And so some of them prefer to do parts of this at a time. The important thing is you cannot round in the middle of the problem. So whatever else you do, there can be no rounding. So let me show you how I could break this down one step at a time. So maybe I'll sort of take it from the top to the bottom. So I'm going to start with the log 40. So I could go log 40. Okay, so I've got this decimal. So now I need to divide that by log this stuff. Okay, so fine. So I could just go divided by log and type this part in. Plus 0.06 over 4. Okay, and I got this other decimal. Alright, notice I'm not rounding, it's all in the calculator. So now I've done the numerator. So all that needs to be divided by 4. So now I could go divided by 4. Alright, so you notice I get the exact same answer I got before. So it's fine to do it this way, as long as you don't stop and round as you go, because then you will be wrong. Alright, anyway, that is the end of this lesson. I hope it was helpful. I will see you on the next video.